Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the derivative of the hyperbolic function. So first of all, we have to know what is the hyperbolic function definition. The sign hx, the h refers to the hyperbolic function. The h is stand for the hyperbolic function. So sin hx, the definition is e power x minus e power minus x over 2. And cosine hx is e power x plus e power minus x over 2. Whereas the tan is sine over cosine. If I divide these two parts, therefore 2 get cancelled, you will get e power x minus e power minus x over e power x plus e power minus x. This is what you will have. Now similarly, the cosec hx can be written as 1 over sine hx, and sec hx 1 over cosine hx. Tan hx, it is 1 over tan, cotan is 1 over tan hx, or you can write it this one, e power x plus e power minus x over e power x minus e power minus x. Both are right. Either you can use this one or the reciprocal of this part. So all are this one. So this is the definition. So this is actually the definition of the hyperbolic function. So we will use this definition in the problem to simplify the function. Now coming to the next one is the derivative of the hyperbolic function. So this is the derivative of the hyperbolic function. It is sine hx cosine hx. Cosine hx, the sine hx. Whereas in the regular function, when you differentiate the cosine x, it is minus sine x. That is the only difference you will have. So here you will have plus. Then tan hx is secant h square x. This is going to be the same in the hyperbolic and the regular function. Whereas here, this is the one difference. So this is one more difference you will have. When you differentiate sec hx, so it is minus sec hx tan hx. So when the differentiation of sec x, it is secant tan. It's a positive, but it is minus. The remainings are same. Now the next one is a inverse trigonometry function. So this one is inverse hyperbolic functions. So this is the inverse hyperbolic function. So how will you write this one? Sine h inverse x. So this one is 1 over square root of 1 plus x square. And here cosine h square h inverse x is 1 over square root of x square minus x. So whereas there it is plus, it is minus. So this is a slight change in the formula. So we have to remember this formula in order to solve the problem, because this is inverse hyperbolic function. So all are the inverse hyperbolic function. Let us go to the identities we have. So sine hx is minus sine hx. It will leave the minus sign outside. It's like an odd function. When you have a cosine h of minus x, it will absorb the sign, it becomes cosine hx. And there is two identities we are using, that is the sine h square x minus cosine h square x, it is equal 1, and 1 minus tan square h is equal sec h square x. So this is the four identities. Whenever we need it, we will use this in our problem. Now let us go with the first problem. So the first one is nothing asking about the derivative. Here asking the find the value of tan. So how will you write the tan? So here I make use of this rule. I make use of this rule. What is this rule? I know that tan x. I know that tan hx is equal e to the power x minus e to the power minus x over e to the power x plus e to the power minus x. Now I want to substitute these values equal 0. X value is 0. When I substitute tan h 0, so e power 0 minus e power 0 minus 0, it becomes 0. E power 0, e power 0. So therefore it is 1 minus 1 over 1 plus 1. So it is 2 over 0. The answer will be 0. So it is any 0 over anything, the value will be 0. So this is the final answer. Here we are not differentiating, just we are calculating the value of tan h0. So just replace x as 0. Now the next one is a proof. So this is the proof part. You have to prove the LHS and RHS. So this is the left hand side and this is the right hand side. So I will take the right hand side, the left hand side. Always take the bigger expression and try to do it the smaller part. Prove the smaller part. So I know this part. What is this? Cosine hx. So I take the left. So what is this one? This is actually e to the power x plus e to the power minus x over 2. So this is the definition. As per the definition, this is the cosine hx and the sine hx is minus e power x minus e power minus x over 2. So this is what you will have the left hand side. Now what is a common factor? So over 2 is a common. Over 2 is a common. E to the power x plus e to the power minus x minus e to the power x. You have to multiply this minus inside. So when you multiply inside, you will get this part is equal plus e to the power minus x. What are the terms get cancelled here? So therefore, e power x plus and minus get cancelled and the remaining things you have, it is 2 times of e power minus x over 2. Therefore, if you simplify further, so the answer will be equal e to the power minus x, which is my right hand side. So which is my right hand side. So that's the proof. This is the proof. Always take the bigger expression and prove the smaller part. Now the differentiation starts here. So find the f prime if f equal. So since it is a product and also it is a e, there is two methods to solve this one. Either you can apply the product rule and simplify. Otherwise, I will use the definition first and make simplify then by then differentiate. So suppose, see here, f of x equal e to the power x. So what is this part? What is this part? This is e to the power x because it is x. If it is 2x, I write it 2x here. But it is x plus e to the power minus x over 2. So this is the definition. When you multiply inside, what happened? What happened? The function. This function become e to the power x with the x, it is 2x plus if you multiply this one, this is opposite sign e power x, e power minus x, it get cancelled, remaining one over 2. Why it is cancelled? Because e to the power x into e power x is what? 1. E to the power x into e power x is what? E to the power 2x because it's the same power. This is the same thing we have done. Now the function is very simple. See here, there is no product rule at all. So I will write it this one as 1 over 2. I will take it in the front. E to the power 2x plus 1. Now, therefore, we will have a differentiation. Differentiate this part. So 1 over 2 is like a c, constant. Now differentiation of this part is, what is the differentiation? E to the power 2x. This is a chain rule. E is over. Now differentiate this part. It becomes 2. And what about this part? This is equal 0. This is equal 0. So what the final answer? So here I can cancel with the 2 with the 2. So simplify answer will be f prime of x is equal f prime of x is equal e to the power 2x. E to the power 2x. This is the final answer. If you do it in the product rule and after simplify, answer will be the same thing but is the longest method. When you use the differentiation, the definition first and then differentiate, it will become very simple one. Once if you do make use of the definition, the function become very small. No need to do it the product rule here. Only the chain rule, you will get the answer. This is the benefit. Now here I cannot use the definition here. Why? The reason. The next problem here. So I cannot use the definition. Lazim you have to go with the product rule. Why? Because there is x. In the last problem we will have a e power x. In the definition e power x it will be simplified. But here it is x. We cannot do, right? So I have to go with the product rule. So what are the product rule? Since it is a product of two functions, so the product rule is, so f prime of x is equal, so fg, right? So this is f, g, f, g, f prime, here g prime. So what is the differentiation first? So I write it here, f prime g plus f g prime. So what is the derivative first here? The derivative of x is 1 and cosine hx will be the same, plus x will be the same. What is the sine cosine hx, which is a plus sine hx, maafi minus. There is no minus here. So therefore you will have cosine hx, if you simplify, plus x sine hx. That's it. So in the question, it is not asking to simplify. So this is the final answer. If the question asking and find the derivative and simplify, I will make use out of definition, but then simplify. There is no need. So only you have to calculate the f prime. Now the next rule here, next rule, we will have a product rule. So we will use here, this one is the product rule. This one is product rule. This one is a product rule. Now let us go with the next one. Let us see what happened here. So this is f over g. So this is going to be a f over g. So f over g means what? It's a quotient rule. So I have to use the quotient rule here. So write the formula first. So in order to solve this one, I have to write it f prime of x equal, that is g square g fixed f prime minus f fixed g prime. So this one is f prime of x is equal, this is, you have g. What is g here? Sine 2hx, sine 2hx whole square, and this is going to be a fixed. Sine h2x is a fixed. Now, what is the derivative? What is the derivative of sine? Cosine. Cosine is nothing but is a regular function. So, cosine differentiation is minus sine. Why we are writing minus? Because it is not a hyperbolic function. Next, minus f is fixed. Cosine x is fixed now. What is the derivative of the sine h2x? Sine to h2x is cosine h2x. This is done. Now you have to differentiate the inside. This is actually the chain rule. So when you differentiate 2x, it becomes 2. So it becomes 2. So this is the final answer. So I can simplify. You can write it as it is because you cannot simplify this part. Minus sine h 2x. Therefore minus 2 cosine x cosine h 2x over sine h 2x whole square. So this is the derivative of the given function. So here in this problem you will have a quotient rule, the trigonometry function, hyperbolic function. So all together you will have here in one problem. Let us go to the next problem. Find y prime if the y is given by this. So here it is a chain rule because there is a function of function. So you have 1. I have to differentiate len. Then tan hx. This is the number 2. This is number 2. And 3x, which is 3. So you have a 3 function, 3 differentiation you have to do. What is that? First, y prime len. What is the len differentiation? 1 over tan h3x. This is done. This part is over. Now tan h. So tan differentiation is secant h square. This is the whole thing is 3x. So tan is also over. Into many students will write it plus or this one, so it is product always. What is the last part? When you differentiate 3x, it becomes 3. So finally the answer will be y prime equal 3 secant h square 3x over tan h 3x, tan h 3x. This is what we will have. Now we will go to the next one. We will solve one more problem with the chain rule. See here. Here also chain rule. Why? because you will have a function of function. How it is a function of function? This is number 1, tan hx, tan h. Then number 2, len. And number 3, this one. Or otherwise, you can write it the same function. If you write it this one simplified form, you will write it this part. If you want to write it this one as a further, as per the rule, so we know this tan h log. So whenever a len of power, I will bring the power here. Is it right? So I will bring the power 2 times of len x. Is it right? So this is what you will have, the property of len. So then we will have what? 1, number 1. This is number 2, only 2. If you do it with this part, you have to do it the 3 function. But then you have to simplify. Now I will go with this part. Here what happened? Y prime is equal. What is tan h? Tan h is secant h square x. X is nothing but here 2 len x. This is done. This part is over. Now what about the inside? The next one. 2 is a constant like a c. And if you differentiate a len, it becomes 1 over x. It becomes very simple. If you apply the property of the log, so it becomes very simple. So this is the derivative. So you will have here the secant. This is 2 times of secant h square 2 len x over into x over x. So this is the final answer. Now the next one we will have also the chain rule, but it is the inverse hyperbolic function. Same rule we will do it. The first one I have to go with this part. The first function cosine h inverse, and the next one is 2x. So let us start with this one. Y prime is equal, as we know, cosine inverse. What is cosine inverse? From the above, cosine inverse 1 over square root of x square minus 1. See the difference. When you have a x here, I have to make it square. Is it right? I have to make it square here. So let us try with the same thing, but here you have x is 2x. Here it is that x is 2x. Therefore, the value will be 1 square root of whole square minus 1. But what is your x now? The x value is here 2x into. Therefore, this part is over. When you differentiate 2x, it becomes 2. X become 1. Now simplify. You will get the answer y prime is equal to 2 times of square root of 4x square minus 1. That's it. Now the last problem of this video, we have a long function with the chain rule. So this is a combined. So you have all the things which is combined here. So let us solve the problem first. So here first we will discuss about the first part. First you will differentiate the power. This is number 1. Number 2 is secant h. Number 3 is inside. So this is the 3 things you will do it in the first. Let us try. First, y prime is equal 2 times of secant h len x. The power is over. When you differentiate the sec, so it becomes what? Minus sec h x. X is nothing but len x, and tan h x len x. So this is the definition for the number 2. So this is the number 2. That is the secant, and this is for the power. Now what are the last part? What are the last part? Len. What are the len differentiation? Len differentiation is 1 over x. It is 1 over x. So this is the number 3. So first part is completed. The first one is completed. Plus, you will have a big plus here. You have a plus here. Now I go with the next one, which is this part, which is this one. So first you will do it sine h square inverse, and then this part. So how will you differentiate this one? It is 1 over square root of 1 minus 1 plus. It is 1 plus here. The x square. Is it right? But the x value here, it is given as x square. So I write it x square. Then this is over. The next part. What is the next part? X square. It becomes 2x. It becomes 2x. Next, the third part, which is a tan inverse. What is a tan? You have to go with again. This is number 1 and this is number 2. So what is the definition here? Plus, I write it here, plus tan differentiation 1 over 1 minus x square. So this is the x square. But what is your x value here? So which is equal square root of x, square root of x. After that this is done. Now when you differentiate the root function, it becomes 1 over 2 root x. After the next step, only you have a simplification. So what are the simplification you can do for this one? So the first part, I can use y prime is equal minus, I multiply front. So minus 2 times of, this is secant h and secant h. It is 2 times. So I write it secant h square of ln x. This is the first part. Multiply done. So it is tan h ln x. This is a only one term. All together over x you will have. All together over x you have. Plus 2x over square root of 1 plus x power 4. Then plus 1 over, this is what? 1 minus x. This is cancel. Root and square get cancelled. You will get 1 minus x into 2 root x. So this is a simplified answer for this question. So this is a very important complicated question. The first part you have 1, 2, 3. So this is power, secant, length. Done. This is done for the first one. Next one, sine h inverse. Sine h inverse, x square 2x plus. Then third part, we have a tan h inverse. This is done. And root x, this is done. Correct? So all together we will have in one question. So you can see, you can view the PDF file in the description box. Thank you.